We're going to talk now about equations that lead to quadratic equations. So they're not going to start out as quadratic equations, but in order to solve them, they will lead to them. I'm going to start with a radical equation. Here we have the square root of 3x plus 1 equal to x minus 1. And you remember earlier we showed where you could square both sides of this equation to eliminate the radical. So if we square the left-hand side, we just get 3x plus 1. If we square the right-hand side, we get x squared minus 2x plus 1. Now I'm going to turn this around. I'm going to put the x squared minus 2x plus 1 on the left, and the 3x plus 1 is going to be on the right. And so I can just subtract 3x from both sides. And so if I subtract 3x from both sides, that'll give me a minus 5x. And then if I subtract 1 from both sides, the 1 will cancel, and I'll just get nothing for that. So 1 minus 1 is 0. So there I have a quadratic equation, x squared minus 5x equals 0. And now we can solve this by factoring. So factor out an x here, and we get x times x minus 5 equals 0. And then the solution would be x equals 0 or x equals 5 for the answer. But if you check this, you'll see that 5 is the only answer that works. So the 0 doesn't work, only the 5 works. Alright, now here's a rational equation. And in this rational equation, I need to eliminate the denominator, and the least common denominator is x minus 1 and x plus 1. So I'm going to use that x plus 1, x minus 1 as my lowest common denominator. And so to eliminate the denominators, I'm going to multiply each term of this equation by x plus 1 times x minus 1. So if I do 12 times x minus 1 times x plus 1 x minus 1, the x minus 1s will cancel. And so here the x minus 1s will cancel, and I'll get 12 times x plus 1, which I write here. And then when I multiply 12 over x plus 1 times x plus 1 x minus 1, the x plus 1s will cancel, and I'll get 12 times x minus 1. And then over here I get 5 times x plus 1 times x minus 1, and I know that x plus 1 times x minus 1 is just x squared minus 1, so that would be 5 times x squared minus 1. Now let's clean this up a little bit. We can distribute the 12 through, so we get 12x plus 12 here. And distribute the 12 through here, we get 12x minus 12 here. And then over here, if I distribute the 5, I get 5x squared minus 5. And so now you'll notice that 12 minus 12 is 0, so that cancels. And I get 12x plus 12x equals 24x. So I get 24x equals 5x squared minus 5. Well, let's move the 24x to the other side. Let's move it over here to the right. And when you move the 24x to the right, you're going to get 5x squared minus 24x minus 5. And then we can factor that into 5x plus 1 and x minus 5. So you factor it into 5x plus 1 and x minus 5. And then set 5x plus 1 equal to 0. And set x minus 5 equal to 0. And then solve each of these. For 5x plus 1 equal to 0, subtract 1 and divide by 5, and you get x equals negative 1/5. And for x minus 5 equal to 0, just add 5 to both sides, and you get x equals 5. Now, I said here for you to be sure and check the domain. We don't have any domain problems here, because if you go back and look, the two things that x could not be in this problem would be 1 or negative 1. And since neither answer involved 1 or negative 1, we don't have a problem with those two answers that we got. Okay, now another type that you can solve is you can use a use substitution to reduce problems to quadratic equations. Now, let me show you how this works. If you look at this equation, it's not a quadratic equation, but if you look at this equation, notice that this term here, y to the fourth, is actually the square of y squared. So actually we could use what's called a u substitution here, and we could let this term be u. So we'll let u be y squared. And then when you square that, when you square y squared, don't you get y to the fourth? Sure you do. So if u is y squared, then we can say that u squared is y to the fourth. So in other words, we can replace the y to the fourth with u squared. We can replace the y squared with u, and we get a quadratic equation in terms of u. So we turned it into a quadratic equation. Now this quadratic equation, u squared minus 17u plus 16 equals 0, factors into u minus 16, u minus 1, and if you solve that, you get u equals 16 or u equal 1. But let me caution you, remember, we're not actually trying to solve for u, we want to solve for y. So that's where we go back to our substitution. Remember that u is equal to y squared. So if u is equal to y squared, all right, then we can replace here, I can replace u with y squared. And so instead of saying u equals 16, I get y squared equals 16. And then I can solve that equation by applying the square root theorem. Y would be plus or minus the square root of 16. And since the square root of 16 is 4, y would equal plus or minus 4. Okay, and then this other one here, I can replace u with y squared here, and I have y squared equals 1. And then when you apply the square root theorem, you get y equal plus or minus the square root of 1. So y equals plus or minus 1. So that one actually has 4 answers to it. Plus 4, minus 4, plus 1, and minus 1. All right, now here's another one. Here notice that x to the 1/3, if you were to square that, you would get x to the 2/3. So that means if I let u equal x to the 1/3, then u squared can be used to represent x to the 2/3. So then if I do that, then I can replace x to the 2/3 with u, replace x to the 1/3 with, x to the 2/3 with u squared, replace x to the 1/3 with u, and I get u squared minus u minus 2 equals 0. And then that factors into u minus 2, u minus 1 equals 0. And then if you solve that, you get u equal 2 and u equal 1. But again, we're not trying to solve for u, we're trying to solve for x. So go back up here, remember, u is the same as x to the 1/3. So I can replace the u here with x to the 1/3 and get that x to the 1/3 is 2. Now x to the 1/3 is really just the cube root. So you know that when you want to solve the cube root, and you want to get solve a cube root equation, you can cube both sides. So let's say I cube x to the 1/3. If I cube x to the 1/3, I get x. And then if I cube 2, I get 8. So if I cube both sides here, I'll get x equals 8. And then for the other answer, u equals 1, I do the same substitution, replace u with x to the 1/3, and then cube both sides of this equation. If you cube x to the 1/3, you get x, and if you cube 1, you get 1, and so x would equal 1. Okay, now one more. This one has square root of x, and of course you know that if you square the square root of x, you just get x. So we could let u equal the square root of x, and then u squared would equal the x, and that way we could replace the x here with u squared. We could replace the square root of x with u, and we get this quadratic equation, u squared minus 7u minus 8 equals 0. Then you can factor that into u minus 8, u plus 1, so you get two solutions, u equals 8 or u equals negative 1. But again, we're not trying to solve for u, we're trying to solve for x. So remember, u is the same as square root of x, so let's replace this u with square root of x, and we get square root of x equals 8. Now, if we have square root of x equal 8 and we want to solve for x, we just square both sides. So if you square the left, you just get x. If you square the right, you get 8 squared. And so 8 squared is 64, so x would be 64. And then we do the same thing here, let u equal square root of x, and we get square root of x equals negative 1, and then square both sides, and we get x equals negative 1 squared, so x would equal positive 1. And there's other types of problems that you can solve using this method, but this is a method to convert a problem that's not a quadratic into a quadratic equation so that you can actually solve it. Here's some more problems by factoring, and I'll just go over these with you real quick. If you wanted to solve x cubed minus 8 equals 0, then that would factor into x minus 2 times x squared plus 2x plus 4 using the formula for difference of cubes. So use the formula for difference of cubes, and you get x minus 2 is one factor, and you set that equal to 0, you get x equal 2. Now if you set this other factor, this will not factor over the reals. X squared plus 2x plus 4 won't factor over the reals. But I'll let you just pause the video here. What I did is I went ahead and set it equal to 0, and then I used the quadratic formula to find the solution to this. And when you get down here to the bottom, you'll find that the solution is actually a complex number. X equals minus 1 plus I times square root of 3. So again, you can pause the video and go through the quadratic formula and see how I applied the quadratic formula here to get the answer to this one. Alright, on this one, the first thing I wanted to do was move the 16x to the left so that I could get both terms on the left, and then I can factor out an x, and when I factor out an x, I get x times x to the fourth minus 16. Well, the x to the fourth minus 16 will factor into x squared plus 4, x squared minus 4. But we're not through factoring yet, because x squared minus 4 will factor into x plus 2, x minus 2. Now, of course, the x squared plus 4 doesn't factor. So I've got four factors here. I've got x squared plus 4, I've got x plus 2, and I got x minus 2. So let's set each equal to 0. Setting x equal to 0 is easy. You just get x equals 0 for the answer. Now, if you set x squared plus 4 equal to 0, you have to solve that using the square root theorem. So let's move the 4 to the other side, and we get x squared equals negative 4. And so x must be the square root plus or minus the square root of negative 4. And the square root of negative 4, if you've studied complex numbers, you know is plus or minus 2i. And then you set the x plus 2 equal to 0 and solve it, and you get x equals negative 2. And you set x minus 2 equals 0 and solve it, you get x equals 2. Well, since x equals negative 2 and 2, I just went ahead and wrote that as one expression, x equals plus or minus 2. So here you have 5 answers, 0, plus or minus 2i, and plus or minus 2. And then I have another one here. So this last one I'm going to factor by grouping. So take the first two and factor the x squared out. I get x squared times x minus 3. And then take these two and factor minus 1 out. I'll get minus 1 times x minus 3. And then I can factor the common factor x minus 3 out. And so I get x minus 3 times x squared minus 1. And then you can factor the x squared minus 1 into x plus 1, x minus 1. And so now I have 3 factors, x minus 3, x plus 1, and x minus 1, and their product is 0. So if you set these equal to 0, I didn't do that here, but if you set x minus 3 equal to 0, you'll get x equal 3. If you set x plus 1 equal to 0, you'll get x equals minus 1. And if you set x minus 1 equal to 0, you'll get x equal 1. So anyway, this section gives you a lot of helpful hints on solving equations, and some are quadratic and some are not quadratic. In the next section, I'm going to talk to you about solving some applications of quadratic equations.